Okay, so before we get started, I would recommend that you go to the video description to get the GitHub link for this project. I designed these to be something we can go through and build together, so it's in the video description. So this is video 2 in the Kubernetes of the Cloud series, and we're going to look at Azure's offering, which is Azure Kubernetes Service. So we've already done 2 other videos with the same code that we're using, the Azure VM scale sets and the simple Azure containers. And that's where we have a very simple Python-based microservice implemented in Flask. And in the first one, we implemented it on VMs, which is a little heavy because these are micro, they're small, so they don't really need a complete VM. But that's how we did it. We used the VMs and deployed the Python microservice. Then we containerized that same code and deployed it with as a Azure Container app, which is the simplest way to run containers. So what we're going to do is convert all that to Kubernetes using Azure Kubernetes Service. So what we're going to do here is we have a fully automated deployment where we deploy both the Flask app, some containers, some content containers for our little games, and it's all powered by Terraform and shell scripting. So it's an end-to-end solution that you can use and adapt for your own purposes. So what are we going to build in this project? We're going to build a document database for the microservice. We're going to use Azure Cosmos DB. Cosmos DB is interesting because it takes a long time to provision. I've noticed that I've used it multiple projects, and it's always like 8-9 minutes to provision Cosmos, whereas the other cloud providers, the document database, is like that. It's really quick. So then we're going to take the Flask microservices and we're going to build them in a Docker container. And then we also have 3 other containers we're going to build, and they are very simple JavaScript games that I found out. There's a GitHub project that I link here, so you can go see the code and who did that. And so once we do that, we're going to push all those containers, the 4 containers, into an Azure Container Registry. And this one's a little bit different. Instead of multiple instances of the container registry, there's like a repository within the container registry. So we have a Flask app repository and a games repository all in the same registry. So once we do that, we're going to deploy the Azure AKS, Azure Kubernetes Service. This takes the longest of all the build. It takes about 15-20 minutes. Then once that's done, we are going to hook up kubectl to the cluster that we've created, and we have 2 files we're going to run, games YAML, Flask app YAML, and that's going to deploy all our containers within our cluster. And then we have Nginx as an unified Nginx controller, so we have one load balancer, and then there's different paths on the load balancer that you can access the content. Like there'll be a Flask app path that you can get to the APIs, and then there's a games path where you can get to the games. So I guess let's talk about the nature of these Kubernetes services. So is Azure AKS, is it platform as service or infrastructure as service? And it's built as a platform as service and pretty much is, but it has a unique characteristic compared to other platform as a service offerings in that the infrastructure that it provisions for you can see it. And so let's go through the elements of AKS and talk about what it's doing behind the scenes and kind of give us concluding thoughts about the whole PaaS infrastructure, platform as service infrastructure. So first, let's talk about the managed control plane. This is the part that is indeed fully managed with AKS. We don't really know how they're implementing it. It's probably EC2, or not EC2, so it's probably VMs, maybe VM scale sets. But it's totally abstracted. You have a bunch of endpoints that you can interact with, but you really don't know how it's implemented. But when you have the control plane and you tell it, hey, I need a node group, I need an ingress service, a load balancer, it's going to start provisioning infrastructure for you. So let's talk about node groups or node pools. Node groups is what is in AWS. There are node pools here. And so when you describe a node pool, you say, the number of nodes you want, the VM size, the OS, and it provisions resources for you. And so essentially, a node pool gets translated into a virtual machine scale set. And so in our solution, we have two node pools. We have the default node pool, and then we have the games node pool, and you're going to end up seeing two different virtual machine scale sets to implement each pool. So that's the biggest thing. The second thing is, and you can see all the VM instances, you can see the VM scale sets, you can see everything that it provisions. It's completely transparent. So then let's talk about the load balancer integration. Now the load balancer, again, it implements an Azure load balancer, and when you just create a service, it does that. And so you can go in to the console and you can see these load balancers and see how they're configured and whatnot. So one thing you'll notice is all these resources that we're talking about that are provisioned on your behalf, that it transparency allows you to interact with, it uses tagging. So if you look at the tags on these objects, you'll see that there's a bunch of AKS tags that keeps everything straight, and that's how it kind of does all the bookkeeping. Now, there is a downside to this. Since it provisions all the infrastructure, I could screw it up. And I think the quickest way to screw it up is to go mess with the tagging. So it's sort of a double-edged sword. You can customize this infrastructure that it deploys for you, but there's certain things that if you touch, you'll break things. And sometimes it's not immediately obvious. So you have to be careful. So, finally, the whole platform as a service, it is indeed platform as a service, but it's different than the other platform as a service, like a good one that I use is the Active Directory, the AD domain services. It's provisioning VMs for your domain controllers, but you don't see them. Same with Azure SQL. When it goes into and deploys like a Postgres service for you, it's deploying infrastructure, but you can't see it. So that's the big difference, is when these Kubernetes systems deploy infrastructure on your behalf, you see it and allows you to customize it a great deal. It also comes with the ability to shoot yourself in the foot. So that's it for the whole nature of the services and how it interacts with the infrastructure. Now we're actually going to see that, so let's go through the diagram. Now the first diagram is the logical Kubernetes view, and this looks remarkably similar across all the cloud platform providers. You've got, first one, the control plane with Azure Kubernetes Services. This is the fully managed parts you don't see. I took some choice services. There's a lot more services in there. But, the big point is that you hook up kubectl into the API server, and then it can interact with, you can interact with the cluster with kubectl. That's where you do your applies to your YAML and just configure your deployments and services. And so the next part is the node pools. So we have a default node pool, and that's where we run the Flask app API. And then we have a games node pool. There's only one node in this one. It's 111 or actually it's one is a min and one is a max. And so even though it's only one instance, it still uses a virtual machine scale set. So then we have, and that's where we're going to put our games. We're going to use a node selector and say put the games on these nodes, and the default node just gets the Flask app. Then there's a bunch of connected services that we connect. We first connect to virtual networking. We connect to Azure Container Registry. We use the Cosmos database in the Flask app thing. That's, we have to create a Kubernetes account and grant the role appropriately with into RBAC, and then that will allow these two pods to interact with the database. And then the last part is the Azure Load Balancer and the Nginx services. Now, one thing that is different for Azure on this is the load balancer in our configuration ends up deploying a level 7 load balancer, and so we ran into some tricky issues with not having anything at the root because the default health check for the application load balancer looks at the root, and there was nothing there, so it would fail. And so what we had to do is there was an annotation when we created the Nginx services that says here is where the health check path is. And we didn't need to do that in the other ones because we were using a level 4 load balancer, a network load balancer, TCP IP load balancer, and here we're using an HTTP application level 7 load balancer. So that's the Kubernetes view of the world. So now let's look at what it actually provisions. Now, one of the things we're going to go through is Azure's really a lot of slick with this. Is in the other providers, it provisions all this infrastructure and it's all over the place. So you have to go look and see, auto scaling's here, load balancers here. With Azure, it creates in your project you're going to have your resource group. What it does for Kubernetes is it creates a peer resource group where it implements all your infrastructure. So your control plane and your view of the logical services in your resource group, but then it puts the infrastructure in its own resource group because it's very easy to isolate. Okay, this is part of Kubernetes. So, like I said, you're going to get 2 scale sets for each node pool. And even though the games node pool only has 1, it's still going to go do a VM scale. And then we have a load balancer and IP address associated, a public IP address. So that's the infrastructure that it provisions on your behalf. Then, of course, we got the Cosmos DB table and the Azure Container Registry. Okay, now let's look at the prerequisites for how we're going to build this project. Here's what you need. You need an Azure account, you need the AZ CLI, you need Terraform, Postman for testing, Docker. The Microsoft app provider must be enabled. We actually enable that for you and check env. And then you must have this user administrator access role because we use a managed identity on the Kubernetes cluster to grant roles like the Cosmos DB. So if this is your first time doing a video with Azure, you might want to go to our Azure and Terraform Easy Setup, where we walk through how you set up all this stuff with a very simple project. It's just got a VPC and a virtual network and a VM instance. Here we're a little more advanced, so either way, there's an example there that you can try. So at this point, we are going to assume that you have installed all the prerequisites. Okay, so what we want to do is you want to copy this code right here and go to your development environment. I'm using an Ubuntu server within Azure for my builds. You want to paste. And there we've got the project. And so the first thing we want to do is we want to run check env. So we've got check env. And it goes, hey, you don't have user access administrator role. So let's walk through adding that since that's different than the default setup. So I will bring up my Azure Home. I'm going to go to subscriptions. I'm going to click on the subscription I'm building under. And I'm going to go to IAM access control. And I'm going to say role assignments, and I'm going to say add role assignment. And let's go to privilege admin role. We'll go to user administrator, click on that, hit next, and I'm going to select members. I'm going to go and do my Terraform build identity, select that, hit next. I'm going to do the second option, the recommended option, and I'm going to review and assign. And there we go. So now if I go to check env, it works. So at this point, let's start the build. And let's do an apply sh. And while it's building, let's first go over the build methodology. So let's go back to the documentation. And the build has 4 parts to it. The first part is we'll provision the container registry and the network elements. So that one's pretty quick. Then we're going to use Docker to build those 4 containers, the API and then the game apps, and then push it into the ACR repositories. Then after that, we're going to provision the AKS cluster. This takes quite a bit of time. It takes about 15 minutes and then about 8 minutes for the Cosmos DB. It's pretty expensive. And it's also going to do the Flask nodes and the game nodes. And then finally, the last step 4, is we connect kubectl to our Azure Kubernetes cluster, and at that point we can apply these 2 YAML files to deploy the games and the Flask app, and after a little bit of time, the endpoints become active, and we will validate them. So that's it for the build process. It's 4 steps. It's pretty similar to the other builds, and now we'll wait for the build to finish. Okay, the build has completed. So now what we're going to do is bring up the Azure console, and let's take a look as to what actually got built. So let's go to your web browser. Log onto your console. This is the default page, and I'm going to click on Resource Group. And the first resource group is going to be the one that we actually created explicitly, the AKS Flask app resource group. And you can see all the infrastructure that we've deployed in this solution, the container registry. We can click on the container registry. We can look at the repositories. You've got the Flask app and games. This one's is a little different than the other one in that you can have multiple repositories in one instance of the registry. Then we go back and the candidates table, and the candidates table is there. We can go in and say Data Explorer, and you should see John Smith in here. I want to watch the video, candidates table, items, and you've got John Smith. So the candidates tables are there. Then we've got sort of the big kahuna, the Flask AKS instance. So click on that. And you can see, you get into the Kubernetes resources. And this is a more extensive version of the like a kubectl interface in the web browser. So I could go in here and it's going to show me the namespaces, and I can go to workloads, and I can say, all right, let's look at all the pods in the games namespace, or all the deployments, or all the pods in the games namespace. And so I could go in and change that to default to get the Flask app. You click on it, and you can drill down into the YAML. So this is quite a bit of UI built on top of kubectl. I usually just use kubectl, so I don't use these a lot. So I'm not sure how many people in the wild use them. What's interesting is I noticed that there's a new thing in there. It's this run command, which is essentially a way to run a run command kubectl directly. So I can go in here and say kubectl get pods, and it's somewhere it's running this and getting the results. So I could say kubectl get pods -d games, and you'll see those. So even with the web interface, you just have a straight up kubectl command line, which I like. So that's pretty much it for the AKS instance. What we have to do is go look at what it provisioned on your behalf. So like if I do a kubectl get nodes, you're going to see there's one node for the default, and that has 1 to 4, and we're going to scale that in a bit, and then we have the game nodes, which is just 1. So how is that actually implemented? That's the whole infrastructure as code or infrastructure as service versus platform as a service. And so if you go back to our resource groups, and you will notice that there's this peer resource group, this MC AKS Flask App RGC. This is where Azure's a little slicker in how it contains all of this EKS or AKS infrastructure into one resource group. So we click on that, and this is going to give you all the things that we've been talking about, what it provisions. So we've got the default node pool, so I can click on that, and I have my instances running, and then we also have tags. So if I click on the tags here, you'll see all those bookkeeping tags we keep talking about. And so there's 2 node pools. There's the default node pool, which is a virtual machine scale set. There's a game nodes pool, which is only 1, but it's still a virtual machine scale set. So click on that, and you're going to have the same tagging to glue it all together. Then the next thing we've talked about the Kubernetes load balancer, and that has its own tags associated with it. And in the diagram, in addition to that, we have the public IP address for the load balancer. So that's pretty much just what got built. Like I said, it's pretty slick that this has its own interface or its own resource group that isolates all the infrastructure that it provisions for you. So that's pretty cool. So the next thing we want to do is we want to go through and test all the endpoints to see if they all got deployed correctly and just how it all fits together with the Nginx controller. Okay, so to test the endpoints, the first thing we're going to do is we're going to go back to your boot and development environment, and I'm going to run validate again, if I can do it without. And what we're going to get is we're going to get this endpoint right here. So I'm going to copy this, and I'm going to bring up Postman, and we will test those endpoints. So within Postman, you're going to put in the health check URL from validate, and it should run and give you the same result that we're seeing in all of the other ones. So it's got the connected and then the host name, which is actually going to be the host pod name, and the pod IP address is what this is going to be. So let's go look at the various endpoints. First off, notice it's Flask app API. So we're using Nginx to only glue this container resource to this endpoint or to this path. So now I can go and say, let's do candidates, and you got John Smith. Then I could do post, and I could do candidate homie. Then I could do get again, and let's go back to candidates, and we should now have homie and John Smith. So this is the API. There's 4 endpoints. I think we tested everyone except the last one, and that's where you go candidate homie, and it'll just show you the one user. So those are the 4 endpoints. So what we're going to do is take this URL. Let me copy that, and let's bring up the web browser again, and I'm going to put that in there, and we should get an Nginx error because there's nothing routing there. So now what we're going to do is go to the games endpoints, and they're on /games, Tetris. And now we have Tetris. Then I can say /games, Frogger. I'm just going to win once. Alright. Then we have Breakout. And I will fail that. So those are the 4 endpoints, and it's all glued up on this virtual Nginx server where all the routing happens. Now Nginx, I talked about how the load balancer is a level 7 load balancer, and the other one's a level 4. Nginx obviously is a level 7 application load balancer. So here it's just sort of a disconnect because you got 2 level 7 load balancers trying to interact with each other, and that's why we had to use an annotation to get the right health check so it would actually pass and start passing traffic. So that is something unique to Azure. And so we've done that. And so the next thing I think we're going to do is we are going to look at it from a kubectl perspective. So let's go back to our Ubuntu environment, and I'll do clear, and I should be able to do kubectl get nodes. And I've got the 2 nodes, the default node pool and the games node pool. And I'm going to do kubectl get pods. And that's going to show me the 2 Flask app because it's a default. And if I do the namespace games, you're going to see the other ones. And then I could go in and say kubectl describe this guy right here. And describe pod. What I need to do. And this is going to give you, your standard Kubernetes deployment, description. Okay, so what we want to do is let's go back in here and let's do kubectl get pods, or actually kubectl get nodes. And so we've got 2 nodes. So now we want to demonstrate scaling. And so to do that, as I have a stress YAML, so I'm going to do kubectl apply-f stress YAML. And we're going to do a kubectl get pods. And you're going to see that some of them are running, but some of them are not. So if I do kubectl describe pod and look at stress, what you're going to see is it needs the pod trigger to scale up. So now it should be scaling up. So if I do kubectl get nodes, now let's do a nano stress dot YAML. And I only did 2, so let's do 3 now, because it doesn't look like it's so let's do a kubectl apply-f stress YAML. And now I should do kubectl get pods, get pods, and you see more that are pending. So now what we can do is go to the console, and we're going to have to wait a little bit. And let's go into here, and let's go to, it's going to be on the default pool. And our instances, oh, it's already started. So it's already scaling up. So I'm going to give it, it takes a few moments for it to fully initialize. So we will wait until that happens. Okay, after a few moments, you will notice that all of the stress nodes are now in a running state. And if I do a kubectl get nodes, you're now going to see I have 3 game nodes. So it has scaled up. So the only thing left to do here is we're going to do a kubectl delete-f stress YAML. And we should see after a few minutes, we got get nodes, we've got get pods. We're going to let it settle. And those 2 more extra nodes that got created from the default node pool should go back down to 1 after about 5-6 minutes. Okay, so it takes quite a bit longer for it to scale down, but if you go look at the Azure console after about it was about 7 minutes, you'll see that it's now down to 1. And if I do kubectl get nodes now, you will see it's back to 1, 1. So it's back to its base state. Alright, so this is pretty much done with going over the project. This is a complete example that you can use to make your own. And so these services are a little bit expensive, so as usual, you want to be a good steward of your cloud account. So you want to go and destroy. Okay, so now let's talk about the AKS specific issues. Okay, so the first AKS specific issue, which really isn't necessarily AKS specific, but it has to do with your networking. So your virtual networking, you're going to deal with a CIDR budget of how many IP addresses. And Kubernetes is unique in that each pod gets an IP address. So when you're budgeting how many IP addresses to reserve, you need to think out how many pods do you have. So I have applications that I support that have thousands of pods. That means thousands of IP addresses, which can kind of be a pain to negotiate open CIDR box with the client. But just keep that in mind. You need to keep in track that each pod requires an IP address. The next issue is the default load balancer that AKS provisioned for us was a level 7 load balancer. Now that caused some problems with Nginx because it's also a level 7 load balancer, and so it was trying to figure out which health check to use. And by default, it uses slash, and there was nothing at slash from Nginx, so it wouldn't route traffic. So we had to use an annotation to specify the GTE health pipe, good to go, and once that worked, the traffic would get routed properly. The next issue has to do with auto-scaling. For the auto-scaling, you have to create a Kubernetes account and attach a managed identity that can actually provision new VM by interacting with the VM scale set. So until you attach that account with the proper identity, and that's why we need the user access, is we create that managed identity and we use it for several different contexts. So yeah, so you need to set that account for it to function. If it's not functioning, you'll look at the logs and you'll say permission denied, and you just need to grant the right role. Finally, I guess not finally, the resource isolation for the infrastructure is really cool with Azure. The other Kubernetes instances, you have to kind of root around and see the infrastructure. Here, it isolates it all in its own resource infrastructure group. It's parallel to your resource group, and it's really easy to see what infrastructure that Kubernetes provisioned for you. The last point has to do with the Kubernetes support cycles. There are 14 months. AKS allows you to buy extra support through ESM. I think it's Enhanced Security Manager. Not really sure what that acronym is for. But you have to buy the premium SKU for AKS, so there's an extra cost. You get a year. I read up about it, and AWS, the document says they will upgrade you, but AKS says that after a year you're on your own. You get no updates. There's no support from Microsoft. So this can kind of be a pain with if you're dealing in an industry where it's highly controlled and regulated, because your SDLC cycles may be months, and so it's not trivial to just say, okay, we're going to use the next version of Kubernetes. It requires a little bit of planning and testing. And so what happens is it may take several months, and you just you need to plan for regular updates. I have some clients that have servers that are still running Windows Server 2022, or not 2022, 2012, and it's 2025. So in regulated industries, they don't update as much, but with Kubernetes, you have to. You have to keep current. You can get about 2 years of support, and then it gets really sketchy. So that is it for the AKS video. We have one more to go, which is the OG Kubernetes, the Google Kubernetes engine. And at that point, we've covered all the Kubernetes across the cloud.